In 6.3, part 2, we're going to look at trigonometric functions of angles to express one trig function in terms of another based off what the example asks. All right, there's a few things that we have to make sure that we know. Reciprocal identities, that the cosecant is equal to 1 over the sine, the secant is equal to 1 over the cosine, and the cotangent is equal to 1 over the tangent. I advise that you guys have these directly into your notes for the next few examples. Quotient identity is a tangent is sine over cosine. Think about it. Tangent is y over x, y being your sine, x being your cosine. And the cotangent, just the reciprocal of that, cosine over the sine. Then a few things about the Pythagorean identities. I want you to keep this in mind that sine squared plus cosine squared equals 1. Well, that's just really the Pythagorean theorem. Remember that the cosine is x and the sine is y, so really that's just x squared plus y squared equals r squared, or a squared plus b squared equals c squared. But for our Pythagorean identities, sine squared plus cosine squared equals 1. So a few more based off of that. Tangent squared plus 1 equals the secant squared, and 1 plus the cotangent squared equals the cosecant squared. Now we'll refer back to these for the next examples. Okay, here we go. It says express the secant theta in terms of the sine where theta is in quadrant 1. Now they'll state this where theta is in quadrant 1, meaning that it should be positive. All right, so the sign should be positive. So let's just go into this. So it says, where is the secant? We're looking at the secant and trying to change it only in terms of the sine. Okay, now since the secant is equal to 1 over the cosine, I'm going to actually use that, and then I'm going to use one of the Pythagorean identities, and I'm going to do a little bit of something to it. Well, so my first step, I'm going to say, okay, the secant of theta, step 1, secant of theta is equal to 1 over the cosine of theta. I'm on my way. I don't want to use the cosine. I still want it to be I still want it to be the sine. So I look up here and I say, oh, the Pythagorean theorem here, Pythagorean identity here. If I solve that for the cosine, I'll have it in terms of the sine. So let's just see what I can do. If I subtract the sine squared and take the square root, I'd have cosine of theta equals the square root of 1 minus the sine squared of theta. All right. And keep in mind, I'm going to keep it positive because it's in quadrant 1. So step 2, instead of putting the cosine, I can put 1 over the square root of 1 minus the sine squared of theta. And this is my final answer. It is all in terms of the sine, and it's in the first quadrant. If it had been in any other quadrant, I may have had to make that square root negative. Next example. Okay, it says, let's write the cotangent times the cosecant in terms of only the cosine where theta is in any quadrant. I know you guys are doing some of this in chapter 5. We're going to keep on going. All right, so let's just change this. It says the cotangent of theta. I'm going to change that right away. I'm going to change the cotangent. So step 1, change the cotangent to the cosine of theta over the sine of theta. Remember, I only want it in terms of the cosine, so I know that right now the sine is not okay. The cosecant, I'll change that according to one of my identities to 1 over the sine of theta. You can see that right here. Okay, step 2, I'll just multiply. Cosine theta times 1 is the cosine of theta. And sine of theta times sine of theta is sine squared of theta. So far, so good. I only want it in terms of the cosine, so I got to do something with the sine squared theta. Keep in mind, this one says where theta is in any quadrant. Okay, step 3. I can replace that sine squared right here, this first Pythagorean identity, this one here. I can replace that. If I solve the sine squared by subtracting cosine squared, I would have sine squared of theta equals 1 minus the cosine squared of theta. So now I'll just use the 1 minus cosine squared theta. So step 3 is cosine of theta, which is fine, divided by 1 minus the cosine squared in place of the sine squared, 1 minus cosine squared of theta. And this is my final answer. Everything is in terms of the cosine. So those are just a few examples. You do a few more examples in your homework. If you have any questions, you can ask me or Ms. Zara. You can also ask your classmates. And I think these are pretty straightforward. You just have to put a little practice into them.